Here. So this video will go through this assignment and we'll talk about using FET so we can use as a way to learn how to use a voltmeter uh, to measure electric potential. And we're also going to go through and kind of figure out some stuff with uh, what's something called the loop rule. So I'm just trying to build the circuit that is present in that first question. So we've got something like this. And if we draw circuit diagrams, the generally accepted way to do things with circuit diagrams is to have everything be kind of straight lines and sharp corners. So that's why I'm not just doing this with one or two or as few wires as possible. I'm trying to make it look the way a circuit diagram should look. So that is a circuit that is very similar to this one. We have our battery and a light bulb, and this is 0.1, 0.2, 0.3, 0.4. What we're doing with this thing is we're going to put the black probe of our voltmeter. That voltmeter measures electric potential. And what it does is it compares the potential at 2 points and tells us what the difference in potential is. So we're going to go through and measure the potential at all of those 4 points and record these values here. So 0.1, it tells us that the black probe will be put at 0.1 and it's going to stay there. And then the red probe is going to go from 0.1 to 0.2. And then later after 0.2, it'll go to 0.3 and 0.4. So the first one is when they're both at 0.1. So there's my voltmeter, and 0.1 is the negative side of the battery. And now what a voltmeter does, so I'll stop and kind of change cadence a bit. Take a breath, hear this part. What a voltmeter does is compare the electrical potential or the voltage at the tip of the black side, gotcha, to the tip of the red side. So if I put this black probe here, the voltmeter is saying, okay, that's 0 volts. What is it? How does where this red probe is compare to where the black probe is? So if I put them both at the same place, I'm saying, hey, this is 0. What is it here? And it just tells me, hey, schmuck, it's the same. It's 0. They're both at 0. Yeah. So if I have both black and red at position 1, the electric potential of a charge there is 0. So on this thing, I can say, hey, that's 0. Now I'm going to go and I'm going to move just the red one to position 2. So now I move just the red one to position 2, which is the positive side of the battery. And here we see that that is now 9 volts. So now if a charge at this location has 9 joules per coulomb, or a charge there has 9 joules of energy, just where it's located, right? The battery at that point in like the elevator stats, the battery has given everything 9 joules of energy when it's there. So now I can just say here at position 2, I'm at 9 volts, 9 joules of energy per charge. So the potential there is 9 volts. Now I'm going to go to position 3, which is just before the bulb. And if we stop and think, do wires use electrical energy? You can stop and think about that. You don't need to answer or say anything out loud. But if we think, do wires use electrical energy? Our answer, what we get here, will kind of tell us something special. So if I put it here, just before the bulb, we see that our potential, our electric potential, is still 9 volts. So that tells us that this wire did not use any electric potential. That's what I was saying earlier, where it's like a really good super tube for charges to flow. So at this position 3, the electric potential is still 9 volts. And now we'll see after the charges go through the bulb and they're at position 4, you'll see how much electric potential they have once they've gone through the bulb. So through the bulb means like down here, I'll put the red probe there, and we'll see how much energy they have here. And there, we're down to 0. So every charge that goes through the bulb uses up completely all of that electric potential, right? So if we go with conventional current, so we can follow the direction of flow in a more conventional manner. So these charges have no electric potential. The voltage is zero. They go through the battery. The battery is like an elevator, pushes them to the top. Now they have 9 volts. This is just like walking down the hallway. This isn't changing any energy there. They go through the bulb, and the bulb takes that energy that those charges have and produces light. So instead of having electrical potential or electrical energy, they now give off light, which is a different type of energy, and then back to the battery, zero. Kind of, sort of, we're hoping. So then when we're back here for position 4, we're back to 0 volts. And if we're going to measure just across the battery, well, I can take this and I can just go like that. Just across the battery, 9 volts. 9 volts. If I'm going to go the potential difference across the light bulb, you'll notice here I made these all negative because those bulbs are using electrical energy. So if I go like that, negative 9 volts for that bulb. Bloop. There we go. And now this is the spot that we need to emphasize with what we just did. This is the equation, the one equation that we've got for today. If we're going to go through, this loop rule says whatever the battery gives, the other things in the path will take away. So the battery provides an electric potential difference, the bulb uses it, we end up with zero. If there were multiple bulbs, we'd say the electric potential of the battery minus bulb 1, minus bulb 2, minus bulb 3, whatever, would all end up being zero. So this is the equation that we would use, that we reference for this. This is like our conservation of energy, or a weird way of doing a conservation of energy equation. My computer clock is ahead of my phone clock. My computer clock says 11. So people that are in the school building, they might, the timelines are a little bit odd. You might be moving pretty darn soon. So if you got to go, you got to go. I want to make sure we do this last part here. This says a step diagram. So what we're doing here is we went from 0 volts here up to 9, and then down back to 0. So our step diagram for this is one that starts at 0, goes up to 9 because the battery gives it potential. We're at 9 volts, and then that bulb uses 9 volts. The bulb takes 9 volts of potential from the charges. We go back down to 0 there. The option above would have like 2 batteries, since there are 2 steps, and then also 2 light bulbs 2 steps down. This diagram would have 1 battery and then 1 step down, 2 steps down, 3 steps down. So that would have like 3 light bulbs. This diagram would have 1 step up, so 1 battery, and then 2 steps down, 2 bulbs. The circuit that we just did, 1 bulb, 1 battery, there you go. I don't remember if I did a second one or not, and I did. So if you got to go, you got to go. I've kept you along. I kept you a bit. So if you got to go, peace. Have a good one. If you don't have to go and you have some time and you want to just get this thing done, we'll go through, and I'll go through to try to finish up the rest of these as we're going. And I think this is the last one, and then the next. Oh, I didn't put the last. Usually there's the, hey, check your score, make your improvements. I forgot to add that on there. So we'll go through with this one. 1 battery, 3 bulbs. I'm just gonna make the change here. So let's see. We'll get rid of that one. We'll throw these things in. Bloop, 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 bloop. And I think the one had like, did it have a bulb on each side? So I'll try to make this one. Yep. I'll try to make this one look a little bit more similar, just visually, to what we had there. Oops, come on. Yarp. There we go. So that's the same idea. We have three bulbs. We're looking at conventional current. Um, and we'll go through and see what we've got here. So one, well, again, we're going to always put the black probe at position one and going to keep it there. And then we'll move the red probe to these different locations. Uh, so, and then we'll put our responses down there. If you have questions, you can please do, you can shoot me an email, or you can throw a comment in on the Google Meet thing. Um, so position one for both the black probe and the red probe. Remember, the black probe is really what says what the voltmeter used to say this is where zero is. So if we're saying that's where zero is, and then we put the red one and ask what it is, probe's going to tell you, yeah, it's zero. So when they're both there, charges have 0 units of electric potential, 0 volts. And now I'm going to move the red probe to spot 2, just on the other side of the battery. 9 volts of potential there. The battery gives every charge 9 joules of energy, or there is 9 volts of electric potential at that location. So on the other side of the battery, 9 volts of potential. Whenever any charge is there, whenever any 1 coulomb's worth of charge is there, that coulomb's worth of charge is 9 joules. And then at position 3, which is just before the bulb, we can again stop and think. So when the charge was here, it didn't have any electric potential. The battery gave it electric potential. And we can again think, does the wire give potential or take potential or do nothing to the charges? Well, if it's a good wire, it does nothing. And that means that our potential shouldn't change. We're still at 9 volts. So at position 3, we are still at 9 volts. Now, position 4 is on the other side. And now this is where we know we know that this is not a wire. We know it's going to do something different than a wire. So we can think, is this going to increase our potential, decrease our potential? We can be fairly certain that a bulb is going to use energy. So our electric potential is going to be less than 9. The charges go through the filament, they come out, and over here, we're down to 6 volts. Now, if I made all of these bulbs differently, we could end up getting different numbers. So it's right now, all of these bulbs are identical. So we'll get some similarities here. But that means that a charge here is at 9 volts of potential, and a charge here is only at 6. So we go back here. That was position 4. At position 4, all charges have 6 volts of potential. And then position 5 is just before our second battery. And again, we can think, hey, do wires take energy or provide energy to charges or do nothing? And they do nothing. So our potential is the same here. Just before this bulb, we're still at 6 volts. So at position 5, we're at 6 volts. Then we go to position 6, which is just on the other side of bulb 2. So we're at 6 volts. We go through the bulb, and then we're here, and we're down to 3 volts. So this bulb took an additional 3 units of energy per charge. So at position 6, we have 3 volts. And we can think here we're just on a wire. This wire should not take energy from charges. It should not give energy to charges. It should end up being the same. Sometimes it's nice just to double check, so I wouldn't harm anybody or foul anybody for just checking. So right there, we're still at 3 volts of electric potential at position 7, just before that bulb, still at 3 volts. At 3 volts here. Then the charge goes through the filament and it ends up at 0.8. So we go through the filament and now we're here and we're at 0 volts, no electric potential at that point. So at position 8, we're at 0 volts. So you can kind of see that we have this like, hey, we were at 0, then up to 9, then a step down, then a step down, then a step down. If we took our screen and tilted it, this would kind of be our step chart, our step diagram, right? Well, bloop, bloop. So if we do a little screen capture here, copy, you copy. You probably can't see this stuff going in the background. But if we take that step diagram, I'll just paste it in here so we see it. And I apologize, that isn't a step diagram. That was the way we ask those questions, right? Come on, you can do it. Paste. Lordy, lordy. So if we take this, and we rotate, that's a lot like our step diagram. We're at 0, then we go up to 9, down to 6, down to 3, down to 0. And so the potential difference across the battery, if we just measure the battery, that's at 9 volts again, right? That's just doing this across the battery, 9 volts. If we check just across the first light bulb, we can do that two different ways. We can go up and say, hey, well, the first bulb started at 9, ended at 6. So the difference between those is 3 volts. Or we could just go here again and measure there to there, 3 volts, a -3 because the bulb is using that energy. And since all of these bulbs are identical, they will all take that same 3 volts. And then when we go down here, the equation for the loop rule, we have this one says, hey, the battery gives us some energy. Bulb 1 takes some. Bulb 2 takes some energy. Bulb 3 takes some energy. And we're down to 0 volts there. And I guess I should be more careful with my language. That's pretty sloppy. The battery provides some electric potential or some voltage. Bulb 1 takes some electric potential or voltage. Bulb 2 takes some more electric potential or voltage. Bulb 3 takes the remaining electric potential or voltage, and we're left with 0 volts as we go around that loop. So as we add the electric potentials, or as we add the voltages around a loop, they add to 0. The battery provides electric potential. The other items consume it or use it. And then when we look at this, like we said before, we started at 0, and the battery is kind of like that elevator giving us 9 volts. And then we went down a step of 3, down a step of 3, down a step of 3, because those bulbs are identical. Each one of those steps was 3. If we made those bulbs slightly different, then they would still have a total drop of 9, but it wouldn't necessarily be 3 volts each time. So there you go. Submit. That should be the whole kit and caboodle. View your score. And if you want to, you can then go back and edit your responses using that. So that's the whole thing. That took a little bit longer than I had hoped. I had planned to go a little bit faster, but there's always something that pops up in my brain. So if you have questions, I'll hang out and you can ask. Otherwise, that's it for today. In a little bit, I'll put these videos. Thank you. Have a good one. See you later. Vaya con Dios. Bien. How do you say goodbye in French again? I forget. I don't know. Sehr gut. That's German. Very good. Schnell. Mach schnell. That's German for hurry up. Go fast. I am stopping the recording.